Okay, so we're here with really small things, term 2 for year 8. First thing we need to know is MR, molecular mass. So you can see I've got carbon dioxide, and the way we do this is to know that there's a carbon and there's an oxygen, so I've identified those. We've got one carbon, because there's no number after it, and we've got 2 oxygens. Then I've used the periodic table to look up the big numbers. So the big number for carbon is 12, the big number for oxygen is 16. Now because I've got 2 oxygens, the molecular mass of oxygen is 32. I've only got one carbon, so it's 12. So 12 plus 32 is going to give me 44. So the answer for carbon dioxide is 44. It's got a molecular mass of 44. Then we went on to separate the mixtures. You can see there's a variety of ways. The big ones though, filtration, evaporation, distillation, and then chromatography. Chromatography is where we separate mixtures like dyes. Distillation is where we separate mixtures that's mixed together in fluids, so they'll have different boiling points. And then filtration, so sieving is just a rougher version of filtration, but this is where we filter out some solids, so insoluble solids, something like sand. And then we've got evaporation, where you've got soluble solids like salt and sugar. And we need to get the water from that, and the way we do that is to evaporate the water, and we're left with the salt. So that was lesson 2. Lesson 3 is electron structure, and this one I love because there's a definite pattern here. So when we're filling these out, the first thing we would do is to look at the small number now in the periodic table. So where we were dealing with the big number for molecular mass in our first lesson, now we're looking at the small number. So we can see the small number there is 18 for argon. So I would put 2 of these in my first shell, because my first shell can hold up to 2 electrons. And then further shells can hold up to 8 electrons. So we can see there that there's 2 in the first electron shell, 8 in the second electron shell, and then 8 in the third. So the electron structure is 2, 8, 8. And there's some simple rules to follow there. And that was that. Lesson 4 then was levels of organization. So this is to do with biology. We start with the basic building block, which is cell. Many cells would make up a tissue. Many tissues would make up an organ, and many organs would make up an organ system, which then go on to make up an organism. Specialized cells then are cells adapted to their specific function. So here's a couple to read through. We've got sperm cell. Red blood cells and nerve cells are all examples of specialized cells, and each one of these will be adapted in a special way for its job. And I'll just leave that up a second, pause the video if you want to have a read through. Lesson 6 was on inheritance, and this is all about how genes match together to give you the characteristics of your mother and your father. So parent genes coming together to make up that organism. Reflection then is where we've got incident rays being bounced off a flat surface, and then we've got a reflected ray. And the thing for us to know is that the angle of incidence equals the angle of reflection. That's always going to be the same with reflection. Then we've got specular reflection and diffuse reflection. That's where we've got a really flat surface, and you can see that it obeys this rule. But with a rough, dull surface, you can see that the angles, it doesn't obey this rule. So the angle of reflection then is not always the angle of incidence. And then refraction, where reflection is the bending, the bouncing of light, refraction is the bending of light. And there's an example of that pencil going through there, because water is a denser medium than air, and that's why the light is being bent. Now what's going to happen is the incident ray is going to come in. This dotted line is called our normal, and if it's going from a less dense material to a more dense material, we say that the line of the path bends towards the normal. What that means is it gets closer to the line. So this angle here is going to be less than this angle here. And that would work the other way then. If it was coming back out into air, then the angle would go away from the normal. And that was year 8, term 2, really small things, very briefly.